Okay, so when we would like to go for this bubble sort, so sorting now is going to be taking more efforts, because we would like to be able to change a lot of these. Sometimes a lot of these values have to be changed. So to be able to sort these, we're going to be sorting them from smaller to largest, which means ascending order. We can do the same thing in descending order, it doesn't matter. We just need to change the way it works. But this tool here, this online tool, allows us to do that in ascending order, so we're going to use that. Now the thing that what needs to happen, and I'm going to click on this step because we would like to see step by step what is going to happen. Now the step 1 is that phase 1, the largest item, is going to be put into the position 16, which is because the arrays have 16 elements. We're going to be finding the biggest element inside the array, the maximum, and we're going to put it into the last, because that's what it is. When we sort them from smallest to the largest, the maximum is going to be on the right. So that's what we're going to be doing. And how we do that, we're going to start comparing 2 by 2, and let's just do that. We compare these two. If we found that the one on the left is smaller than the one on the right, like here, we don't touch them, because they're already on the right order. The smaller should be on the left, the bigger should be on the right. And then we just move to the other two. If we find the smaller is on the left, we don't touch them. But if we found that the smaller is not on the left, we flip them, we swap them. So the thing is going to be, we take this one, put it into the temp, and then put it back here. Because swapping them, this is what happens. We need to take this, put it somewhere, and then move the second one, and then put back in its place this one. And then we keep moving. That's what it does. Every time the one on the right is smaller than the one on the left, we swap them. And if it's not the case, we don't touch them. Now, as you can see, this is going to be doing, just going to push the bigger values, is going to push them to the right, one step at a time. Now this does not need to be changed, because the one on the left is smaller than the one on the right, so we're not going to be touching anything. And we just keep doing this same time. So now let me just run, so you're going to see that this is basically what happens. Every time it just compares if they are smaller. It takes a lot of time, but it's an interesting way how to fix things. Now, if we'd like to implement this, what should we do? If we'd like to implement this, well, let's start by doing step by step. We're not going to be doing the whole algorithm at once, but just let's start one step at a time. Let's just try to find the largest and put it on the right side, the same way that this algorithm was working. So let's create a new, I'm going to close all and create a new project, call it sorting, and I'm going to just, let's put everything in one place for now. So I'm going to have the array to be random, so let me just copy the code for the random array. I don't want to spend time doing that, so basically I'm just going to be asking the user to give me the number to, no, I'm not asking the user, because this is just sorting and then displaying the array how it is sorted. So I'm just going to take this code to declare an array, and then to initialize it with random numbers. I'm going to make it from 0 to 100 for a change. Then I'm going to display the array. Then later on I'm going to do the sorting, and then I'm going to display it again so I can see it's sorted. So let me copy, close, and then paste. Now I'm going to just make it to 100. So this is just going to give me 20 numbers like this, but let's make it like 16 to be the same size of the example that we just looked at. Now we have these random numbers that we'd like to sort them from the smallest to the largest. Now what we are going to be doing, if we'd like to be doing the same thing, comparing them one by one, 2 by 2, so we need to have a loop, right? For what? I starting from 0 until So when we compare until the end. So it's going to be array dot length. And then what am I doing? I need to compare the first one with the one next to it, which is if the array of I is, when do I need to change? When do I need to change? Not when do we need to do some swapping? If the one on the left is smaller than the one on the right, do I need to swap? No. So if it's the opposite, if the one on the left is bigger than the one on the right, then I need to swap. So let's put, now if the array I is bigger than, I can do this whole array plus I plus 1, then I need to do something. What I need to do? Swap them. To swap them, I need to have a temporary variable, and then I'm going to put array.I in it, and then whatever it's array.I now is going to be changed to whatever it was in the other one, I plus 1, and then array of I plus 1 is going to be equal to the temp. Now I have one problem. What is my problem? Just with this. You see, this is a problem. Because I is going to be 0 up to 15. Now 15 plus 1 becomes 16, and there's no index 16. Which means I should be minus 1. Because if I don't, just this code is going to raise an exception, which is array index out of bound. You see this 16 when it comes, because this number is becoming 16 and there's no 16. So that's why I need to make it minus 1, because the last index of the I is going to be this one, because I'm comparing I with I plus 1. This one, yes. If we remove it, what should we do? Something like this? So I need to take whatever it's in I. Basically what's happened here, let me just make a step. When I found that one on the left is bigger, I need to take this one, save it somewhere, because this one is going to take its place. And by taking its place, that means it's going to have the same value in I and I plus 1. Then, because I saved it, I'll be able to put it here. So that's why I need to save it. Exactly. That's what I'm doing. I'm remembering array.I, and then I put I plus 1 into the I, then what was in the temp, and put it back to the I plus 1. Now if I do this, I'm sure that at the end it's going to be the maximum. Let me try this. I'm going to this is just displaying the array, and you know what? I'm going to take this code, put it into a method, public or private, I don't care, static. This has to be static, right? Because I'm going from the main that is static. It's void. It just needs to display the array. You just give it an array, whatever it is, and no, like this, and it's going just to display that array. Now the advantage of this is that instead of doing this, I'm just going to display the array. It's going to be able to display the array. Now the array before, let's say I'm going to display something before and after. Now let me run this. This is before, this is after. Let's just realize that at the end, this is the highest number in the array. Now what I need to do, the same thing again, but this time up to the array size minus 2. So how to do that? So another for loop until I see something that can be put into another loop. Well, I'm just going to copy and paste. Now I need to start from here until not minus 1 but minus 2. Why minus 2? Because I need to do these things up to this time. I'm comparing the last thing I need to compare is 14 with 15. So I don't need to reach 15, I need to go for 14, which is minus 2. Yes? It's going to be a nested loop, but I just would like you to be able to see it. So what would be the loop? Let's see it. We will be able to do something like that, yes. Now let's just see. You can see now it's now the second largest is at its position, right? There's nothing bigger than 90 here. No. So between 90 and 95 there's nothing, so that's why this is its place. If we just would like to continue doing the same thing, we just, as you can see, I just need to increment this thing. So it becomes 1, then 2, then 3, then until it's the last one we need to compare. It will be, yes, one next to the other. Because, like for example here, 1990, what happened? Yeah, it was random, I forgot, yes. The other 90 was gone. Yeah, but this is if if we'd like to see the same values, let's just reduce this number so we can have fewer values. Let's say from 50. Now I will have less values, so I'll be seeing some repetitions, but not the ones I was looking for. Yeah, I just would like to make it 10, so it will be much easier to find some repetitions. You see the 8, 8. So if they're repeated, they're going to be next to each other. So now, yes, I'm sorry. Of course, it will take more time, but at least we got things done. Do you have a better option? For now, no. But we will learn better options later. We will improve. At least we have something that we can improve on. So now, if I'd like to have this, I can just make this to be a loop inside of a loop. So the whole thing here is going to be inside of another loop. Why while? I know exactly how many times I'm going to repeat, so it's better to have a 4. I'm going to have another 4. What I'm going to do, hold on, I'm just, first of all, it will start from 1 because this is where it started. I'm going to make this to be a variable. It's going to change. But it's going to be 1, then 2, then 3. What's the maximum? 1, 2, 3, because I always subtract by 1, 2, until what? Until what? Array.length? Minus 1? Let's try to understand. Why is this a problem? I don't know what this was. Now let me just cancel because I don't know what happened. This how it was like this. And then let me just make sure that you know what I'm doing. Which was 1, that was the last one that we put. When it was 2, that was this one. 3, the third one. Then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which basically if it's 15, that's going to be the last thing I'm going to compare between these two, and that's it. So what I need to do is another for loop. I'm going just to type it myself. For int j, for example, or n. It starts with 1 because that's the value that is going to be here. and then this n is less than a dot length because it's 15. That's the array dot length. Well, if I put less than strictly, that means the last value is going to be 15. The last n will be 15, right? So that's what I want. If you'd like to put -1, I don't mind, but you have to put equal, because I want this to be equal to 15. That's what I just said. When it was equal to 1, we put it here, then 2, then 3, then 4, up to 15. So we need to have it equal, or just like this. And then n plus plus, because n is going to be increasing, and that's it. Now this, inside this, the first time n, oh no, this should be n. The first time n is 1, next time it's 2, next time it's 3, and so on. If I run it, it's in increasing order. Of course, it takes a lot of time and does more than what it needs, but there are better options, but we're going to be learning those better options later. At least now we know how to have a sorting way to do that. Yes, this one. Because you remember the first time what we did is that we did not put, we just put something like this, and then we had an exception. We did something like this and we had an exception. Why this exception? Because I is going to become 15. Array of 15, that's fine. But array of 15 plus 1, that's array of 16, that doesn't exist. So that's why I should not be having the I to become 15. So it was -1. And that's where we started with 1. And that's why in this outer loop, we don't start with 0, we start from 1. As you can see here. So I don't have the exception. Yeah. Okay? Welcome to the sorting. That's not that difficult, but